Okay, now in 7.2, you're going to have a lot of problems like the one we just did, where you're doing sine is raised to some power. You can't see that, can you? And then cosine is raised to some power. And then you'll also see some like this one, where you have tangent raised to some power. In this case, tangent's raised to the first power. And then secant is raised to some power. So they're a lot alike. This one's a lot like the one we just did. And I'm looking at this problem, and I'm thinking this. I got to think in terms of, okay, the derivative of tangent is what? Secant squared x. I'm thinking u substitution. Well, I certainly could get a secant squared x out of that, but I'm going to have an extra secant x. That's going to be trouble. What's the derivative of secant x?
Secant tangent.
Secant tangent. That will do the trick. If I do this, the integral of, let's take that secant cubed x and write it as secant squared x times secant x times, and now I got my tangent x that was at the front of the problem, dx. And so I'm setting this up for u substitution. Do you see it? U will be what? U will be secant x. And then the derivative of u is secant x tangent x dx. There it is. It's all in there. Once you kind of can see the right thing to do as far as trig identities go, or how you're going to tackle this problem and deal with those exponents, some of them are real easy then. Oh, let's see. This will be the integral of u squared du. That's it. Here's the du, and this is u squared. All right, so what's the antiderivative of u squared? U cubed over 3 plus c. Resubstitute secant x. Secant cubed x over 3 plus c. There it is. There's that problem.